one way that we can pre-process our long database sequence is by constructing a suffix array. The motivation here is that if you think about it, any possible match of any given query sequence to my long database sequence, that position at which it matches is by definition the beginning of a suffix. So for example, let's say that the positions of my database, let's say this is index 0, 1, 2, 3, 4, 5, and 6. ATC, I can look at it and see that ATC appears right here. Well, this sequence, this substring of my database, this is the start of the suffix that begins at position 2. So ATCGC, this suffix starting at position 2, starts with this query. What about GC? I can see that there's two suffixes in my database, the one starting at position 0, which is the entire string, and the one starting at position 5, which is this last suffix. Both of these suffixes start with GC. Therefore, I could transform my pattern matching problem into, out of all of the suffixes of my database string, which suffixes start with my query? If I can solve that question, I can solve my original problem. Each of those suffixes is defined by a starting position. That starting position is precisely the position at which my query appears. So what do? So a suffix array is basically a sorting of my database's suffixes in increasing alphabetical order. So let's construct all of the suffixes. I have, starting at index 0, I have GCATCGC. Starting at index 1, I have CATCGC. Starting at index 2, I have ATCGC. Starting at index 3, I have TCGC. Starting at index 4, I have CGC. Starting at index, oops, that's ugly, 5, I have GC. And starting at index 6, I have C. These are all of the suffixes of my database string. If I sort these suffixes, what do I get? Well, and I sort them in increasing alphabetical order from start to end, from top to bottom. So these are my suffixes. Now I have to sort them. So alphabetically, the first one is this one. This one starts with an A. Nothing else starts with an A. Therefore, the first one is ATCGC, which corresponds to index 2. Okay, ATCGC. The next one, so nothing else starts with an A, so starting with C, I have this one and this one and this one. This one is the smallest alphabetically, because it's just the letter C. So index 6, I have the letter C. The next one is, out of these two, CA versus CG, this one's smaller. So index 1, I have CATCGC. Now this one's the next alphabetically large. So 4 is CGC. Okay, that's all the C's. Now I have G and T, so G is smaller. GC, GC, this one is smaller. So then GC. Now this suffix, GCA, TCGC. Okay. Now TCGC is my last one. This is index 3. So TCGC. Okay. So now I have my sorted suffixes. Really, I don't actually have to store every single one of these full-on strings, right? Because if you gave me the start index, I can extremely rapidly produce the exact string, right? If you gave me index 2, I could tell you, oh, that suffix is ATCGC. If you gave me index 4, I could say, oh, that suffix is CGC. So all I really need are these start positions. I don't have to actually keep track of the suffixes themselves because I can produce them on the fly as I need. So for the purposes of showing the search algorithm, I'm going to keep these suffixes here to make it easier to see. But in reality, I wouldn't actually store any of these in memory. All I would store are these integers representing the start indices, and I would generate the corresponding suffixes on the fly as I needed, including when I'm doing the sorting algorithm. Okay, so this is my suffix array. It's the sorted list of suffixes, but really each index defines a suffix. So it's the sorted list of start indices of suffixes where the suffixes are in increasing order of alphabetical order.